All right, here is 6.3.2. And this is looking at what happens if the longest side squared is less than or greater than the sum of the squares of the other sides. And these lead to either acute or obtuse triangles. So we're going to do both in this screencast. I'm going to prove the situation that we're talking about here. So on the left, let's look at this. We're looking at an obtuse triangle. I've purposely drawn an obtuse triangle in here. And we're going to let C be the longest side. We're going to somehow show at the bottom here that the longest side squared is greater than the sum of the other two squares. And how we do that is that, and this is going to happen in a number of other cases for the rest of this course, where you may create right triangles that are helpful to you. So we're going to create one here by extending BC a little bit and then dropping the altitude, okay? And what we're going to say here is that, like, this is a little bit of a distance of x, and I'm going to call this the height because it is the height, and it's right outside of the triangle. We'll do something similar on the triangle over on the side here where it's acute. I'm going to instead, though, that the h will end up falling inside the triangle, and we're going to still label that little distance x. And so what happens is I've now created a right triangle. And the right triangle is right here. This entire big one, right? And we know from experience that c squared is equal to h squared plus, now I'm going to remind ourselves that this is little a, right, plus x squared, all right? And what happens is that we then look at this. C squared is equal to h squared plus a squared plus ax plus x squared, okay? We're also going to look at this little triangle over here, right? And we know that from this smaller triangle, h squared plus x squared is actually equal to b squared because b operates as the hypotenuse inside that smaller triangle. So if I bring this information down, I now look at this. C squared is equal to, look at that, h squared plus x squared. H squared plus x squared can be replaced by b squared plus a squared. We're going to leave that alone, right? A squared plus ax. Oops, there's a 2. There's a 2ax. Maybe you caught that earlier. There's a 2ax. Now, what this means is that in an obtuse triangle, c squared is equal to a squared plus b squared plus another number, another length. And so therefore, when we have an obtuse triangle, c squared, because it's equal to a squared plus b squared plus a little bit more, is strictly greater than a squared plus b squared. And hopefully that makes sense to you. A squared plus b squared plus, let's say this is 10, right? Makes these two things equal, these two sides equal. So therefore, if c squared is equal to those two things plus 10, then c squared will be greater than a squared plus b squared. On the other side, we're going to do something fairly similar, okay? And we're going to say, for instance, that f squared is equal to h squared plus, now we're going to be careful, this distance is not d, it's actually all of d minus x. D minus x squared. Well, that means that f squared is equal to h squared plus, if I multiply everything out, d squared minus 2dx's plus x squared. Now, you may be saying, gosh, the same thing happens in this little triangle up here. Let's try to get that established, that what? H squared plus x squared is actually equal to e squared. So back to our proof down below, h squared, oops, and I forgot this, plus x squared can be replaced by e squared. Here we go. I'm just going to keep filling those things in. So that's a replacement. I'm going to bring these two down. So plus d squared minus 2dx. And so here in the acute triangle situation, f squared is not equal to e squared plus d squared. It's equal to e squared plus d squared minus a little bit of something. And so therefore, in the acute triangle situation, f squared will actually be less than that sum, right? Because f squared is equal to the sum minus a little bit. That means that f squared must be less than the sum of the two. And hopefully that makes sense to you.